goes lower, and let's see if it has that same problem or not. Okay, so it has somewhat of the same problem, but not as bad of the same problem, which is really interesting. And so if we look at this, so it's got kind of blurry edges. See this? Yeah. So it's kind of the same problem. We're like, they're both doing something off. And I have a suspicion Codex may have broken something when it changed background, is one of my guesses. And it broke the gradient or something because we have this clipping. Yeah, so it's this one spreads it with some color, which is like a little better. And then this one like grays it out. Also, it's kind of cool. We can see our feature blob dancing now, so that we did fix that, which is nice. But yeah, this is the more worrying part. So let's go ahead and show this to Codex and to Claude. So we're going to do one image like this, one image like this. Yeah, let me dump this one into Codex as well. Okay, and let's take the feature PCA. Let's go back to, I want to give it a little more evidence of, that is not the feature one, but this is the feature one. So let's find, I wanted to basically check in this one, does it learn the feature blobs out? And so, yeah, so this was our unconned feature. This was the base one with no init. And it actually, now that I look at it, has a similar problem where these are all kind of splatting around there. And so I'm super curious what that is. I'm basically going to just copy this one as well. I'm going to say, so I've noticed in our runs that we have this problem now. Once we added feature splatting, there is some amount of initialization where the XYZ positions of the splats are kind of clustered in the center, and there's a border background. And before, the splats would all learn to move and adapt to the background and eventually fill it all in. And now it seems like the splats do not move as much in the XYZ direction. So something about our changes to do feature splatting has stopped the background from learning as well, or stopped the position coordinates and the size and the width of the splats from learning as well. I'm not exactly sure what that was or why. It could be a change in the rasterizer, or it could be some sort of subtle change in the training code. We should look at our old code and compare it and see if there's anything obvious. And let's also check the git logs and the changes and the diffs of the files on disk, because we could have possibly introduced this in our changes to feature space, or this could be a more core issue of that we broke in the training code more broadly. Okay, I'm gonna dump that off to Codex. I want to give it one more picture. And on this one, I'm going to talk a little bit more about the difference of the k-ming, because the k-ming one, weirdly enough, is all gray in the background. And then this is orthogonal, I believe, or this is k-ming. So k-ming has like a ring, and then orthogonal is all gray. Okay, so we have some issues we've discovered in our training code. All of the feature splatting seems to have some sort of effect where the points are initialized in the center of the screen and the sizes and positions of them do not get properly optimized. Perhaps there's a break in the gradients or the forward pass. This did not seem to be an issue with the original training code, where even though the initialization was in the center of the screen and the points were clustered, it would eventually learn to spread them all out and learn the entire frame. However, as you can see in the images that I attached, One of them is from the initial run, one of them is from the k-mean run, and one of them is from the orthogonal run. This is before our initialization changes. It still happened. However, one thing that's interesting is that you can see in the k-mean runs, there's a kind of blurry, colorful edge. And in the orthogonal runs, the edges are fully gray. So something that's happening is making it really go orthogonal as only gray. But then still there's this bigger core issue of why don't the splats move and get bigger and or larger like they used to, and why do they seem to stay stuck, clustered in the middle while we're optimizing? Boom, so I'm gonna kick that off for him as well. And so I don't really know what would have caused this. And this is one of the frustrations of agentic programming, where it's like, I kicked this stuff off and I didn't read the code changes. I don't know what code changes they made. I don't know because it's the baseline worked, right? So if we go back to this, let's see, which one's our fast one? This line here, this big drop. This was our baseline. And if we go to the media of our baseline, we have this. And it starts, and it's like the pixels in the middle, and the coordinates are all like this, right? And then by the later steps, it's expanded and it's not just blur in the middle. It's like, as I'm looking at it, I'm seeing maybe it was always doing a little bit of this, because there's a little blur, but I think it gets way less of it. Like by the end, yeah, here if we look here, I mean, it's definitely rendering stuff on the edge there. Like that dog moves out of the kind of, we can look at where the box is, right? And the box is like here. So that's the initialization. And it does learn to move the splats out of the box. It's not doing great, but it does learn to move them out. And so these ones seem to learn, like all of the signal goes to color in the middle, right? And it does learn a little bit to kind of stretch and warp that box, but yeah. I'm interested. I imagine one of my guesses is that we need to tweak the learning rate, because there's a separate learning rate for coordinates and for color, and probably the feature coordinates have now become 10 times larger. The amount of parameters in the features which make the color is 10 times larger than the features for the location and the size and shape of the blobs themselves. And so I would guess it's probably a relatively simple bug that has more to do with the learning dynamics. And so probably what we're seeing is they are learning, because this is helpful to look at this video, because we can see it does learn to move the blobs actually. And so it does, like in this one, it learns to move them as well. And so the blobs move around. So zero initialization, it gets tighter and smaller actually instead of larger, which sucks, but it does learn to animate them and move them, and it's not fully stuck. So I think it is learning, so it's probably not a code issue or a math issue of the like forward backward render pass, but is most likely a learning dynamics issue, where basically all of the grading is going to color and not to movement and position and stuff. So I'm just gonna probably mention that. I want it to think for itself actually as well, because yeah, I just wanna, let's see, what's it saying? It's cool to run tests and stuff. F32 starts with a nearly constant RGB render around blah, 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 blah. That points more to initialization. That's feature background contrast and a full rasterized backwards break. Yeah, I I think I'm right. I think it's checking other stuff. I'm glad because it's gonna run like a bunch of benchmarks and stuff and like get numbers on things, and it might discover some interesting insights that are different. And so I'm gonna tell it now. I'm thinking about this now, and I think probably what happened is when we moved to feature splatting, we did 10x the number of free parameters responsible for color compared to position and width and height and depth and size of the splat. And so my guess is that basically we need to adjust the learning rate to account for that, is my thought. But yeah, also it looks like you're talking about white background incentive, which is interesting. I don't know what that was exactly, but yeah, I guess the background we need to align. There should be like a empty background feature as well. Okay, so as I was talking, it started correcting me, which is funny. And so I think it's probably more right than I am. The other thing I was thinking is like there's, and it's the same thing it's kind of suggesting here, is like the way we handle background's different. And so before you just like a white color and you kind of know like, oh, white's not right. And so it learns to penalize that. Whereas I don't know how well it's going to do that now on this stuff. And if we did, I'm going to ask you some more questions. So how did background work before? Did we render white and then did we penalize if the background was shining through to make sure it doesn't have, basically penetrates through the entire cloud? And then how would we fix this for features? Like, do we want a specific background feature now? And do then we not apply the colorization to the feature? Because it seems like it's probably kind of learning some weird blend where it like blends background features and then tries to predict a color and kind of cheats instead of just penalizing it for missing and not finding any splats or something. So do we need to basically better add the output for splats? And it says we need to add an alpha output for V5 feature. So it sounds like, did we remove alpha from splatting? If so, that's a problem. And that sounds like what we need to fix. And I just also want to like talk about how our rasterizer handles alpha. If it passes through full alpha, do we record that? With some alpha, do we record that? Does it get the alpha per each thing it goes through and combines them? Because we do want some amount of future blending. And so let's reflect holistically on the original alpha handling, the current alpha handling, how they vary, how the original one should have been, and if it had any issues, and then if we made things worse and or better with the feature splatting. Okay, yeah, that's a mouthful, and yeah, it's basically like I don't know the code is like the short answer is what that oblique block of the text means, and it's like I'm confused. We made a bunch of changes that I didn't read. Please help. But also it's like the changes are pretty good. They kind of work. It's differentiable. It renders, and we need to stop and think about, I don't know if we handled background well to start with or how we handled it. Honestly, I can't remember those design decisions, and I kind of glossed over it on the first pass. So we may have not had, background's kind of special, right? Because if you go through all your splats and miss, like, should you just penalize that? Should you just like make it white? And then your gradient's going to be what? Because if it goes to the background, there's nothing to change. There's no free parameters on the background. So you just like zero the gradient, and then like how does it learn to fix that if there's no penalty, right? It needs to be like, no, you should have like, we should have hit something. It's like, how do you make it learn to expand splats? So I'm going to ask that question. So what happens if we miss everything? Wouldn't we get a zeroed out gradient basically? Because if we hit the background, we've intersected with no free parameters. So how can we encourage a miss to then have gradient to make other things larger or something like this? Do we also just need to maybe initialize that we have some larger, more blurry opacity splats or bigger coverage, or is that just a band-aid on the real fix, which is making sure a miss has a gradient that encourages it to not be a miss to possibly expand the size of a splat later? And in general, how do we optimize the gradients on misses so that like it knows to basically grow a neighbor to like encourage the nearby color to hit or something like that. Or do Gaussians always struggle with that? And that's an issue deeper in the methodology. I just want to, we need to like explore the theory of splats here basically in depth and make sure it really dials the stuff in. And then I'm gonna just copy this like whole other thread over to, also let's make sure we think about learning rate, and if it was maybe just a small learning rate thing where did the more free params make an issue, or if we have more free params for color, is that going to bias our learning rate dynamics in any way, and do we need to adjust learning rate? Or I guess it averages things out, so maybe not, because each param gets a little less LR anyway, and so that's fine, but just consider that stuff as well. I think the learning rate thing's wrong, because when I think about it, you're going to divide that across them anyway, so there's 32 times more parameters, they get more gradients, but then it divides the application of the gradients anyway, so it's like probably not a big deal. And yeah, let me go ahead and cancel that out. So what I'm gonna do is I'm gonna dump that big Claude thread too. I'm gonna say, here is me talking with, and let's do, above is a big dump of me talking in a thread with Claude. And so could you kind of stop and reflect on the things you've discovered and the tests you've made and the things that we've discussed there? Do you have any insights that are better? Do they have missing insights? Do you have missing insights? How do these two threads of conversation combine? Who is more right, and what is the ultimate set of things we really want to do? Okay, I'm gonna look back at and read what it said as well. I just want to combine threads because basically it's always good to just dump them into each other and give them more context. But we'll say old F3 starts with RGB splat colors against a white background. F32 starts with a near zero feature raster against a near zero feature background. Then a weakly random initialized colorizer maps to that gray and teal. And you know, now I want to say, can you also give me a quick summary of the initialization work we've done and as a handoff to the other scientists to investigate? Because what initialization tests have we written and what did we tweak? So I want to just like basically write a quick handoff so Codex knows about the initialization work that this thing did. And so yeah, missed pixels are not actually zero gradient. The gradients on a splats parameters come from that pixels loss, looks like. If splat I contributes, splat contributes to pixels if exceeds alpha threshold. Every Gaussian has infinite tails. The Cole threshold. Okay, so there is like a long tail in a Gaussian that basically, yeah. Gaussian tails reach further than their visible footprints. That's nice to know. So each spot gets small gradients. The missed pixel loss is strong. Many iterations. I bet one thing is if we just trained it longer, you wouldn't notice and they would probably grow. But like it's one of the reasons we test short is like, let's make sure we get it right from the start and don't just spend more time and money covering up for our failure. So we're gonna get this right. The gradient on splats marginal tail contributes also strings 5 to 10%. Yeah, of course. Blah 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 blah. Bigger scale as a band-aid, kind of what I was thinking. Yeah, densification is the other option where you just like add splats where things are empty. And so it assumes densification isn't needed because the decoder learns to map tokens to wherever splat should go. So yeah, it's like, how would we fix densification in a tokenizer scheme? I don't know that, yeah. I think this is the big thing. We have some non-alpha-aware compositing, basically. Yeah. I think we possibly want to start with a higher alpha threshold, a little bit more variance in our XYZ coordinates, and the alpha composite. So yeah, it sounds like the alpha compositing is just broken. did we trace that full stack, and how did it used to work for background for the alpha compositing with non-feature splatting, and how does it work now, and what would the fixes look like, and where? Is it just changes to the rasterizer mostly? Yeah, it sounds like that's the big one. I think that makes sense. That we probably broke something in the rasterization in its alpha. But I think that it's not a great sign that the splats are not filling the whole frame to start. I think the initialization could be better. I also think the alpha threshold would be a good idea. I think we want to start that low or higher and then get to a smaller and smaller value, because basically to start, you probably want them all to bleed into each other so it gets a rough scene kind of fast. I think like instead of having a fixed threshold, we probably want to schedule that threshold is my kind of thought there. Yeah, per splat feature direction initialize. Yeah, and then we're gonna hand off this to Claude as well. And so we'll do, go ahead and give the second dump, and then I'll say, oh, which three, we'll say, okay, I added a second dump as well. So can you take a look at this dump, and let's take those two together and think about what went wrong. Sounds like maybe the core issue is rasterization. Also, you changed default configs. Did that already fix it? And what exactly work did you do? And right now, can you not do work right away, but just talk about the full stack and where you think this is coming from, and if there's a few key principal fixes or one key root cause. So yeah, we're gonna basically run everything we've thought through Codex now, and it looks like it actually fixed something, which I need to check in on. So this is interesting. And it changed it to use normalized colorization. I'm just like a little worried that this interacts poorly. Also, what changes did you make? I'm worried you messed things up, because we did add a layer norm to try to normalize our features before we do the colorized MLP. So can you describe the changes you made in a handoff doc that we can share with Claude to make sure you didn't do anything conflicting, and see if we need to roll those back? Yeah, I wish it wouldn't have gone ahead and made this change. Pre-norm camming, yeah, so it added its own norm, but I think we already had a norm that we added, so yeah. And then I think Claude's background incentive diagnosis is the better root cause in my color initializer framing. Yeah, I kind of agree. I think Claude's more right on this one. It's got that kind of stuff, and so what the background now goes through. Yeah, this is the thing. This is the thing here. The background goes through the feature colorizer. And it probably shouldn't. The background should probably say miss, and we should probably have a miss gradient, right? If the feature background maps to gray and teal, empty pixels are no longer white. The MLP can learn reasonable color background from empty feature input. Yeah, this is the thing. That's like, this one doesn't do it, but this one it does. It starts to like learn an approximation of the color background by turning the background features into color, which is like, no. And so then it never learns to like do the right color. Yeah. So the principal fix you'd want is alpha aware contribution. Yeah. Okay. And so let's dump all this into Claude as well. Pitfalls documented. That's from Claude to integrate. So yeah, I'm just I'm pretty sure it's this alpha compositing thing. I want to get it really right and fix it once. So there's test time compute, which is the longer these things think, the better they get. And you can do that yourself. So instead of just like waiting for it to think and use its own thinking tokens, you can just like keep asking questions and keep asking questions and use two threads and copy and paste them back into each other. And Gemini DeepThink, that's actually what it is underneath the hood. So it runs 5 agents and they talk to each other and they say who's right, who's wrong, and then give you a final answer. ChatGPT Pro is the same thing. It's a swarm of agents. They all answer and they all go, is this wrong? Is this right? Is this wrong? Is this right? Try again. And so just the more things you run in parallel that are doing the problem in different attempts, and then the more you have them talk to each other and compare and contrast their attempts, the better accuracy you basically get with LLMs. So I'm like, alpha compositing seems about right, but like what exactly about it? What's the right way to do that? And let's dial it in, like just do not fuck this up anymore. So I'm going to read a bit what they said here. So this is how the old one works, called V5 metal. After all splats, T blah, 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 out. Yeah, so if there's no accum, out is RGB white. So that's before what used to happen. And then the loss propagates through the alpha blend chain. Splats where Gaussian tails reach the pixel marginally, get non-zero gradient, and then expand and migrate. What I'm kind of wondering is like, if the background is a 0 white, how is there a non-zero gradient? And it seems like they can have very weak tails, but like they have very weak tails that give you a little alpha but don't contribute to color. I don't know. I guess if you have a really small amount, but that should give it like 0.001 or something, right? Like it should be a tiny bit of color. So I feel a little skeptical still on that, but let's keep talking to them until they really got this dialed in. Background pixel is not white, so they get a bunch of loss. How background works now. Render, blah, blah, blah. At the end. Okay, so we did not break alpha. Damn, so the obvious thing's not there, but it does train the colorizer. I guess that's the problem. More than anything, the colorizer runs on the background. So before, if you get a background at 0, all of the gradient is going to go to those alpha overlaps. So there's a little bit of a tail of Gaussian sticking out, and all the gradient will push that out. So there's very strong loss. Like, this is white. We need to stretch the splats. Now, the gradient may stretch the splats a little bit, but there's a much stronger gradient that says, turn the background feature into the color I want. So you can kind of see this where like it just makes a bunch of green. It's like, okay, we'll just like treat the background feature as a color and we'll turn it green. Which, yeah, I guess is what's happening mathematically. So cool. That's what we have to sort out here. And yeah, so it erases the background versus content distinction. Yeah, nailed it. You could set it better than I did, of course, because you're the one that figured it out. Claude, thank you, bud. Restore the F3 contract. Alpha mask. Yeah, so they want to do a mask, and then we don't apply the RGB head where there's a mask. That seems about right. Or extend features v5 to expose alpha. Yeah. Okay. Marginally hit, none. Yeah, I think this makes sense. Apply, let me go ahead and use text to speech again for you folks listening in. So it seems like the real issue here is that the backgrounds before, when they were white, the only way to fix them was taking the tail alpha from nearby splats and expanding them, because all of the gradient would have gone to very thin tails of nearby splats and would have moved and or grew them. Whereas now that background gets turned into a feature, which then gets passed through an MLP. So there's a much stronger gradient that learns to recolor a background feature into the desired color rather than ever pushing and pulling the splats. Let's see. Wow, this is a fascinating bug. I feel like I should draw like a Figma chart, because if you don't have a strong understanding of what the heck Gaussian splats and world models are doing and where all these gradients are going, you're gonna just hear me reading a bunch of text and having deja vu moments and being like, wow, this is amazing, but probably not actually understanding anything. So let me go ahead and write a new Figma file. I haven't been in this app in a while, so I'm just gonna take me a while to sort this out, but let me draw what the hell is going on. So this is a super cool bug, and I'm actually like weirdly excited to explain it, but I guess that's why I'm streaming my shit on YouTube, because I have a weird passion for world models, don't I? Okay, so let's do color, and this can be like blue, and I'm gonna go ahead and do, let's do splat, make this guy a little bit of green. I'll try to make this quick. I know the stream's going on forever, so let's do effects, and we need background blur. Oh. Layer blur, there we go. Can I jack it up? Can I do more blur? Can we go like really high? Okay, there we go. So let's do this. So we've got a couple splats sitting like this, and this will be our background. And then we're gonna take some lines. I'm gonna do this, and so this will be like our camera here. So we'll call this cam. So this is our camera. Let me go ahead and fill this guy out a little bit. I'll make the nicest, ugliest camera I can. And it shoots rays at the scene, right? And so if one of these goes through, it doesn't hit the background. The background's like an empty and null space. And so these get splatted back to the screen, and we get blue and green, and if this one hits the middle, so it's gonna have like no opacity, just blue will go back, and we'll get a blue render for that pixel. And then we shoot this one, and it's gonna go through the blue opacity, so it'll get a little bit of blue plus the green, and that pixel is gonna be colored green right there. There's these other rays on the edge, they're going like this, boom, and they hit nothing. And what happens is, in the original model, when it hits this nothing, that goes back to the model, and the gradient's gonna learn, oh no, we need to fill something in there, because it's like nothing's wrong. And so it'll stretch. The nearest splat has a little bit of tail. So you can see, if we zoom in on this blur, it blurs and blurs and blurs, and it just overlaps a little bit. And so that tiny bit of overlap is the only signal going to this ray. And so it's like, oh no, the background's wrong, but we have this nearby splat, and then the gradient is gonna go and make it expand a little bit. And then we'll get a signal, and there'll be something going on. And it's great, and it starts to learn. But now that we have feature splatting, what happens is, let me go ahead and copy and paste this whole mumbo jumbo here, down to here. When this ray goes through, it bounces back this way, And then we run an MLP now. And so this little red block is our MLP. And then out of that comes the color. So before it hits the thing and the color gets propagated back, so it's just blue. Now it hits this and it says we have a feature, and the blue represents a feature that's like a 32-dimensional vector. That turns back, our MLP turns that into a color. And so our bug was that this ray came out, hit the background, bounces off. When it comes back to the screen, our little MLP's here again. And our MLP says, oh, we hit the background. But then the MLP goes, oh, make that a color. So then the loss on the camera never actually realized we're hitting the background. And instead of stretching this guy that's close, it just takes this MLP and is the MLP like, oh, we'll just make the MLP make the background right. And so it's just, it never learns to move the splats. And it's just like, instead of, it's always a little bit easier to cheat with the MLP. And so in the long term, if we could learn the fucking splat, it would fix it and that'd be great. But if a network can cheat, it's always going to cheat. So there's this strong cheat signal, and it just like the cheating is just always dominating. And so what we're going to do is basically add a mask. So this thing is going to always come back and composite to just white. So his background is going to just fail. And it can't cheat with the MLP anymore if it hits the background. So the MLP is not going to be active when we hit the background. And that's the fix. Yeah, shortcut learning and credit assignment problem. Thank you, Claude. You've nailed the precise mechanism, and it's a sharper framing than mine. Oh my goodness. Killing me with the glaze, my friend. Let's see. I think it knows how to fix it. Do you know how to fix it? MLP when we don't hit the background. Something like that. Okay, change is not fixed alpha aware background compositing. Features, I'm worried we doubled up on layer norm now. I'm worried it doubled up on layer norm because it added another layer norm. Like we'd already added a layer norm. So yeah, anyway, we're gonna let Claude work this one out. He's been doing great. ChatGPT agrees. And we're close to this thing really working now. And this is the beauty of machine learning. It seems like it's so easy. We just need to add, like we're gonna do features. We'll just go from 3 channels to 32 and add an MLP. And then you do it and it's like, our fucking network's cheating. And what you really see is like it's failing, and it fails differently in a few different configs. And then it's like, why? And it turns out if you try to add this thing that helps a lot in all sorts of cases, some cases it fucking cheats and makes things worse. And so I didn't think about this. It is less of a problem when you don't have tokens, I think. But I guess not. I guess this would show up without tokens, with just the splats. So whatever, we're gonna fix it. One line change at the loss boundary. Wow. Alpha mask times white. Yeah, so we literally just, this is a one line change at the loss boundary. That's amazing.